You had a job that paid $390 trillion per U.S. hour, worked 24 hours a day, 7 days a week, 365 days a year for 100 quadrillion years. That's about how much you'd make. You had that much money in $1 bills. It actually, I gotta ask the physicists on either side of me, or my brother. They can figure this out. But if you had that many $1 bills, the weight of those bills would form a black hole. Okay, we'll go with that. Okay, so let's take a look at the rules for compressing IPv6 address, how to show it in less space. Now, today, I'm just going to show addresses generically. We're going to talk about some of the different types of addresses. But Thursday, and if you came in a little later, Thursday, I got to start at 8 o'clock. Sorry about that, 8 to 9:30, this Thursday only. We're going to talk about the global unicast address, and this will make even more sense, okay? So for now, just be okay with the rules, and then you'll say, oh yeah, it's not that hard to figure out the network portion and the host portion of an IPv6 address. It really isn't. It's really, really simple. Okay, let's get to the rules. First rule is that you can omit any leading zeros in any of those hex tags. So let's take a look here. Let's take a look at that first one here. Okay, see, wherever you have a leading zero, okay, we can remove the leading zeros. We got 0 there, we got 3 zeros, 4 zeros, 4 zeros, and 0 there. Okay, notice trailing zeros, no, can't remove those. We'll talk more about that, why that's the case in a moment. Okay, same thing here. Leading zeros, we can omit. Now, I'm leaving spaces here, okay, so you can see where I omitted the zeros. Here, same thing. Okay, leading zeros only. Okay, so only leading zeros can be excluded, not trailing zeros. Why is that? Well, if we allowed trailing zeros to be omitted, we saw something like this. Well, we wouldn't know which side the zeros were being omitted on, left, right, or both. Okay, so leading zeros only can be omitted. Okay. All right, this is just from the book, just showing you some examples. Okay. Don't worry about these addresses. Don't worry about what FE80 is. Don't worry about any of that right now. Just take a look that you can remove the leading zeros. We're going to reduce this further, by the way, in a moment. Okay, again, removing any leading zeros. These are just some examples. Some more right here. Okay, let's look at rule number 2. Rules for the second rule is the double colon rule. Okay, so the first rule is we could omit just the leading zero. Okay, and not trailing zeros. Okay, now I could apply the first rule to these all 0 hex tags, but I have a better rule for that. Okay, the second rule says any single contiguous string of one or more hex tags consisting of all zeros can be represented with a double colon. Okay, so what does that mean? That means that second rule is that we can take this whole string of contiguous all 0 hex tags and replace that whole thing with a double colon. Now, that might look like, okay, but where is everything? We'll talk more about this on Thursday when I talk about global unicast addresses and how we really apply this. But but we'll see in a moment that maybe a little bit today, but definitely on Thursday, how this is so easy to tell where the network is, where the host is, and all that kind of stuff. Okay, we're gonna make life really, really simple. The one thing you've got to get over with IPv6 is, let me back up a little bit here. What you got to get over a little bit is this. So this here, what I'm showing you right here, we'll talk more about this, especially on Thursday. This is how the internet sees Cabrillo College. So I can recognize that. I may not even have it memorized, but I recognize it. 2607 F380 ADF. That's Cabrillo College. Okay. This here is the subnet. Okay. Actually, it's a room number. Okay. So I will talk more about that, but that's a subnet. It's actually part of the network. So that's the entire network address. Okay. So that's the network I belong to. This is how the internet sees Cabrillo College. This is the subnet I'm on at Cabrillo College. So there's my entire network address. What's this? This is the host portion of the address. Okay. Typically, we don't care about clients like the computer Rick's on. Okay, unless we're looking for some issue where some problem may lie or some security problem or something. But so this is the so it's not like I have to memorize this. Okay. Usually what we do want to know is our server addresses, and they're not going to typically have this long address. We'll look at those a little later. Okay. We can shorten those considerably to things that we recognize. With IPv6, it gives us incredible opportunities to make things easier for us. So just, you got to get past the idea that, wow, that's so long. I've got to memorize the whole thing. Get past that. Recognize this is your network, this is your subnet, and for your clients, this part is your host portion. Again, a little bit today when we get to this called a global unicast address, a lot more on Thursday. All right, so don't worry about all this right now. Okay, the double colon. Okay, so what happens if you have something like this? Okay, you can only use it once. So what does that mean? Well, you have a couple of options here. You can use the double colon on the first group of all 0 hexstats, okay, and just do omitting zeros on the second group, the red group. Or, okay, you can do the omit the leading zeros on the first part and then the double colon on the second part. Now, which one should you use? It doesn't matter. Does not matter. Now, I will tell you, I like this approach here. I like putting the double colon at the end, if this was the case. Because typically, this is your network portion of your address, okay? Now, there's an RFC that came out that says, well, you know, not best practice, but we kind of recommend that use this one. I don't like that, and I don't have to use it. I can do it my way, okay? It's all about what makes it easy for us. I was on a couple of podcasts. Actually, it was quite interesting this Friday. I was on one of the podcasts. Where is he? I will share this with you. Okay. I was on a podcast with the author of this book, IPv6 Address Planning by Tom Coffeen, as a guest host on The Hedge with Russ White. And we were talking a lot about address. And it's all about making things easy for us, the network administrators. Okay, now you can only use the double colon once. Why can't you use it twice? Because if we had something like this, we really wouldn't know whether it's that, okay? So you can't use the double colon. By the way, if you're noticing that some of these slides have uppercase hexadecimal, some have lowercase, it doesn't matter, okay? A fairly recent best practice says let's use lowercase, but again, it doesn't matter. Cisco iOS, because it implemented IPv6 a long time ago, right now it displays everything in uppercase. We'll look at that a little later. But anyway, little side note there. Don't worry, don't let the uppercase or lowercase throw you. Okay, this is showing some all 0 hexes. Whoa, what's this? Can you have an address of all zeros? You can. We talk about this in routing when we talk about CIS 82, CIS 83 routing. But this, this would be just a double colon. This would be like for a default route, if you're familiar with that. If you have all zeros and a one, well, if you had that, I could show it like that. Now this is with the leading zero still. Okay, we'll get out the leading. We'll remove the leading zeros here in a moment. But right now, just showing all zeros here, right there, just a double colon, something like this. Here's the 3 all zero hextets, double colon here. So does that throw us off? And I'll come back to this, especially on Thursday. But let me just mention this real quick. Let me bring up my ink to go here. Where are you? There we go. So when you see something like this, like, well, what got removed? You've got to remember, how many hextets are there? 1, 2, 3, 4, 5, 6, 7, 8. There's always 8 hextets. Okay, there's always 8 hextets. So just look at what you've got. Either count from the beginning or count from the end. Well, here, this is quite, let's see, we got the majority at the end here. So that would be the 8th, 7, 6, and 5. Okay, so that's the last 4 hextets. That means this is the first hextet. So what's missing, or what's been replaced with by the double colon, is 2, 3, 4. Okay, just count from the end in this case. All right, so here's where we have just one single hextet here. Okay, so 1, 2, 3, 4, 5. Oh, what do I got here? 1, 2, 3, 4, 5, 6. Oh, gosh, I got a mistake there, don't I? Wonder why that's like that. What happened here? Oh, mistake. All right, let's ignore that. Sorry about that. I have to check the book. All right. That's where these examples are taken, by the way, out of the book. Okay, this is showing removing leading zeros and then including doing the double colon. So this would be removing the leading zeros, omitting the leading zeros, and this would be with the double colon. All right, this will make more sense. We're going to go through more examples a little later. Okay, this will, when we get into the addressing, this will make much more sense. All right, let's talk about IPv4 subnet mask and prefix length, because in IPv4, you have the choice of a subnet mask or a prefix length. We're going to see in IPv6, we just use prefix length. So the prefix length means how long is the network prefix, meaning the network portion of the address. So if you remember in IPv4, okay, we can use subnet masks like I'm showing here, dotted decimal, or a prefix length. And again, the prefix length just specifies how many 1 bits in the mask. Let's just go here, 14. 14 1 bits, okay? This would be the dotted decimal, right? So this entire 8 bits is 252. Okay? But it's showing 8 plus 6 more, 14 1 bits. Okay, let's just do one more. Here we have, this is quite easy, 25 1 bits. So 255, 255, 255, and then we got 128 at the end. Okay. Okay, so a little terminology here. Okay, I mentioned, and this is the same terminology we use in IPv4. Prefix is the network portion of an address. Okay, so a lot of times you just say, what's the prefix? Or what's the network prefix? and we mean the network address. You'll hear many times they'll talk about routing tables, how many, how many prefixes are in that routing table. And you're usually referring to how many network addresses. Okay, although they don't have to be network addresses, that's usually what routing tables have. The vast majority, if not all of their addresses, will be network addresses in a routing table for what it uses for routing. The prefix length, okay, that's that slash notation, okay? And that's all we use in IPv6, okay? So we can see here that it's a /64. So if we remember, this is 16 bits, right? Because this is 4, 4, 4, 4, 16 bits, plus another 16, omitted the leading 0, plus another 16, plus another 16, omitted 3 leading zeros. Okay, that equals 64 bits. We're going to see, by far, we're going to talk about this on Thursday. This is the network prefix you're going to see internally in your organizations. Okay, you're just going to use /64s for everything, which we're going to see can make life incredibly easy. Why is that? Because typically the first, depends on the network, we'll talk about these, but I'll show you an example here at Cabrillo. This is 48 bits here. This is, for Cabrillo, this is how the internet sees us, as a /48. This isn't our address, I'll show it in a moment. But again, 16 plus 16 plus 16. This is how the internet sees us, as this /48. Matter of fact, let me show you the real thing. Let me show you the real thing. I'm going to put this right here. Let's make this nice and right there. Okay. Oops. Put that over here. Let's make this nice and big so everybody can see it. This is the address on my computer. This is so easy. Did I not copy everything? I did not. Let's see. Oh, I didn't copy everything. There we go. That's better. All right, this is the address on my computer. Okay, now Cabrillo, we received this from our ISP, okay? So if I look at this is, again, this is 16 bits. We're gonna talk more about this on Thursday. The internet sees Cabrillo College as what we call a /48. Anything beginning with these 48 bits, with this group of hexadecimal digits, is Cabrillo College. Okay, so any packets coming in right now, Cabrillo, IPv6, begin with this. Now, once it gets to Cabrillo, we have subnetted, adding another 16 bits. Okay, we'll talk about this. Okay, this is actually we'll talk a little bit about this today, but this is, now we've extended our mask to /64. Okay, so this is actually part of the network portion of the address. We don't borrow bits from the host. We don't have to do that game in IPv6. Talk about that on Thursday. We can, but we don't need to. Okay, so this is the network portion. Okay. So it's very easy to see, oh yeah, Cabrillo, this is the subnet that I'm on at Cabrillo. Subnet, okay, we'll just put it like this. And this is me, my computer. Okay. So the prefix length of this address is actually /64. All you got to count is 1, 2, 3, 4 hextets. 4 times 16 4 times 16 is 64. That's how easy it is in IPv6. Okay? Except under unusual circumstances, and I'll mention one of those at least on Thursday. This is what you're going to see in all your networks. Makes it incredibly easy. Yeah, Pamela.
Rick, thanks. I was just wondering, before you said we don't have to subnet an IPv6, so we just subnetted because we wanted to know where this was, or?
Oh, yeah, let me clarify. Thanks for asking.
Okay.
We do subnet, but you're gonna see on Thursday, it's really easy. I'll give you a preview. This is what we got from our ISP. Okay? And this we know, we'll talk about this on Thursday, but this is the host portion of our address. This I use for my subnet. It's already predetermined.
Okay, thank you.
Okay, so in hexadecimal, I can use whatever numbers I want here, hex. So we'll take a look at that, but it's very easy. I can use whatever I want. Any hexadecimal numbers I want here to create subnets. Remember in IPv4, we have to borrow bits from the host and determine how many subnets we want and all that.
Yeah.
None of that game's here.
Okay, thank you.
I'm going to create a subnet for one of the other rooms here. Okay, what should we start it with? How about, let's say it's in the CTC, so the Computer Technology Center. I'll put a C here. That's a legitimate hexadecimal number. And I could maybe just give it 001, make it its first CTC. So you can have the CTC, we'll give it a whole bunch of subnets. Okay. Can have it a whole bunch, it's that easy to create subnets. So we'll see more of that on Thursday. Okay, that's the interface ID. Okay. Oops, I gotta move this over, don't I? There we go. So prefixes are always identified by the prefix length. Okay, now we'll talk about prefix lengths of different values, but let me mention again. Move this over here so I can always refer to it. As far as internally, okay, we are going to have /64s. Okay. Why did you have to put that little line? What if I do that? No. There we go. Which means that this is the network portion of the address. That's always what we're going to be seeing internally. Okay. But we'll talk about some of these other prefix lengths here. 30/32, 16 plus 16. Okay. This is a /48. This is a /48. This is how the internet sees Cabrillo. This is what our internet service provider said. Cabrillo College, you get this. That belongs to you. Do whatever you want with all of this. Now they know what we're going to do here. They say this will be your subnet. These will be your hosts. Now, can we go further? Yeah, we'll talk a little bit about this on Thursday, a little bit today. Notice I go from here to here, it's 4 bits. This is in bits. 4 plus 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 4. Okay, that is 32. 16, 16. If I go another 16, that's 48. If I go one more hexadecimal digit, just one digit, that's 52. That's 4 bits. Okay. That's another 4 bits. 52 to 56, 4 bits. These are hexadecimal digits, 4 bits each. That's 60. That's 64. Now you may be wondering, can I do? What about 62? Can I do 62? That falls between the two. You can. We'll talk more about this on Thursday, but don't. Oh, unless you really, really, really have to. You don't need to. We have so many addresses in IPv6. you don't have to split a hexadecimal digit. And we'll talk more about that on Thursday. But something like this means that the first two bits of 62 would mean these two bits belong to the network portion. These two red bits belong to the interface ID, the host portion. Don't make your life any more difficult. You can if you want, okay, but don't. Simple is better than complex in networking, okay? Just because you can doesn't mean you should, okay? Okay, so prefixes. Okay, here's some different prefixes. Now, I said typically we're going to be using /64. So the first four hexadecimal, first four hextets is the network portion. But why would we see some of these others? We'll talk about that because I alluded to this already. Our ISP will see us as this, as a /48. But internally will be a /64. Again, more on Thursday, but so anyway, typically our hosts, very seldom are they going to be anything but /64s. Okay. There's really no reason to have a /48. You're not going to do that. Okay. So we'll talk about why /64. Why that part in part, there's reasons for that. Okay. So we'll get there. Why, if you notice here, okay, what I'm showing you here is if this is a /64, right? We have 64 bits that represent the network. And specifically, this is our subnet. Now, what does that leave us with? Okay. What that leaves us with is another 64 bits for what we call the interface ID or host portion. Okay. So we have 64 bits here. But we also had the 64, I'm going to get my colors here, 64 bits here. Okay. 64 bits for the network portion, 64 bits for the host portion. Okay. And if I add those together, of course, that's where I get my 128-bit IPv6 address. Okay. And it's that easy to read, right? Hey, oh, there's Cabrillo. This is the subnet at Cabrillo. This is me at Cabrillo. Wow. You don't have to, with the IPv4, if you're on a natural octet boundary, if you have a subnet mask that's a 255.0.0.0 or 255.255.0.0 or 255.255.255.255.255.0, makes it easy. You can do the same thing. See the network and the host. But anything in between, which is the most common, you're going to have stuff in between. Okay, then you got to figure out, what's my network address? What's the range of hosts? What's the broadcast address? You have to do that calculation in your head unless you recognize it within your network. With IPv6, just look at it. Just look at it. There it is. Okay, this is a subnet on this network, one of many. Okay. All right. So this is kind of cool. The global routing prefix. We're going to talk more about this next week, but the global routing prefix. So I should actually, let me do something here real quick here. Where are you? Let me grab something here. And see, I've tried to shorten this a little bit. All right. There we go. Why did okay. Let me show you something here real quick. 1 second here. There we go. I knew I had you. There we go. There. All right. So talk a little bit about the difference between IPv4 and IPv6, right? So in IPv4, we have a 32-bit address. We have a network portion and we have a host portion. And our subnet mask determines where the network portion ends and the host portion begins. Now, internally, when we want a subnet, we have to borrow bits from the host portion to create subnets. Okay, so we have to borrow bits, which reduces the number of hosts per subnet we have. Okay, it says we're extending our network, but now we're having just a fewer hosts per subnet. Instead of 100 apples, maybe I have 10 baskets of 10 apples each. Instead of 100, again, instead of having 100 apples, instead of having 100 total apples, host portion, I have 10 baskets of 10 apples each, let's say. Now for IPv6, okay, it's a 128-bit address. Okay, the network address is usually going to be 64 bits, meaning internally what you're going to use. Okay, but there's two parts to it. Okay, there's what they call the global routing prefix. This is what your ISP has given you. This is how they see you. Typically, this is how the internet might see you. Okay, but this is, for Cabrillo, here's that global routing prefix. Okay, they gave us 48 bits. Now, a 48-bit global routing prefix. What does that mean? Okay, let's take a look. Okay, that means between the 48 and the 64, what's between 64 is the boundary because we want to use this for our hosts, our interface. That leaves 16 more bits. So between here and here's our interface portion here, it left this. That is our subnet ID. So this is our, what we call our global routing prefix, how the internet sees us, how our ISP sees us. This is what we get to use as our subnet ID. It's already built into IPv6. Already built into IPv6. This is how we can now subdivide our network. And this is a host in this network, particularly this specific subnet. Okay. So 16 bits. How many subnets can I have? I can have 65,536 subnets. Okay, yeah, from 4, and we'll talk more about this on Thursday. From 40 hextets, 000 to FFFF. Okay, now how many hosts per subnet can I have? Let's take a look at the host portion. We call it the interface ID. Why do we call it the interface ID? Because host is an older term. Back in the old days, what received IPv4 addresses back in the 80s and 70s and 80s and even in, was a host computer. That's what we call it. If it wasn't the mainframe, we called it a host computer. Well, even mainframes we called hosts. But it was just a computer. Now, anything could get an IP address, just a medical sensor, a webcam, doesn't matter what it is. All right. So we call it the interface ID. How many bits do we have in that interface ID? We have 64 bits. That's how many hosts per subnet we can have. Look at this, 18 quintillion. That many hosts. Not in our network. That's in just one subnet. So just in this subnet here, this device can be one of 18 quintillion hosts in that one subnet. And how many subnets can we have? 65,536 subnets. And people that are new to networking, they're like, oh, okay, this is great. Yeah, sounds good. The issue is people that are kind of been at this for a long time and learning IPv6 and been working with IPv4 a long time. The mindset is, wait a minute, I'm wasting all these addresses, 18 quintillion. I don't need that many. I'm wasting that. No, we're not cutting binary trees down or anything like this. We're not wasting anything. This is all designed to make our lives easier. Okay, we're not wasting anything. It's not about conserving IP addresses anymore. It's about making the nomenclature, the structure of these addresses in a way that we can do address planning much easier. Yes, Tom Coffeen, my buddy there, talks about that. All the ways that you can structure addressing to make it easy for you internally to manage your addresses, where you don't have to have all these slash 27s or slash 19s and what's the first address, last address, decimal, and all that. No, everything is this easy. We make it easy. We don't care. This is not about that you're going to have 18 quintillion devices. This is about you don't care. Okay, you've got plenty of room. It's never going to be a limitation. All right, let's do this. Let's take a 5-minute break. Then I'll come back to this here and talk about the global routing prefix and what we get from our internet service provider, what we can get from our internet service provider. Is everybody doing okay, by the way? Is this making sense? Doing good?
Making sense. Yeah.
All right, good. All right. Okay, let's do 5. Remind me to start the recording.
Recording stopped.
A little cold here. Runny nose or something, that time of year, yeah. Righty, let's go ahead, get started some more here. Let me start.
Rick, you wanted a reminder about recording?
Thank you.
Okay.
What I need is something let me start it before I start talking. Resume.
Recording in progress.
All right, thank you. What I need is something to come out of the computer to hit me on the head when I'm starting something, you know, when I've started teaching, I haven't started the recording. It should just take me and go, Rick, stop. I can't tell you how many times over the years that has happened. Okay. Let's talk a little bit about the global routing prefix and how that comes into play. Again, just a reminder, 8 o'clock on Thursday. Oh, it's going to be a long day. That's going to be a long day for me, but I'm sure it's a long day for all of us, right? So we'll start at 8 o'clock on Thursday. We're going to actually talk about global unicast addressing. What is the global unicast address, Rick? Okay, the global unicast address, and that actually gets us to where we're leading into right now. You notice I have these addresses here that I've said, and actually got more than one. We'll talk about that as well. That has Cabrillo's prefix, okay, the network portion, subnet, and the host we'll talk more about that. But I have this address up here as well. It's called a link local address. I'm going to introduce that today. But we are going to focus on Thursday on the global unicast address. This is a globally routable address. Okay, so what I mean by that is, we'll see that on Thursday. When I'm connected, as I'm connected to Zoom right now, actually, this is the address that is being used for my connection to Zoom or anywhere else I go. Google, Netflix, Meta, it's just, the majority of things I connect to, okay, is using that address. No network address translation. Okay, this is how they're seeing me. Okay, from my device all the way to them. All right, so let's talk about this global unicast address. And one last thing I want to mention is Canvas. I'll update that today with the PowerPoint from today's class. Okay, so global routing prefix. This is how the ISP sees you. So first of all, remember the last 64 bits, those last 4 hextets is the interface ID. Okay, so that's reserved. So we know the other 4 hextets is going to be the network portion, the prefix. Okay, it's going to be divided between our global routing prefix and a subnet ID. So let's say our ISP gives us, at UCSC, they got a global routing prefix, and I'll show you the exact addresses on Thursday. What they got the first 32 bits, first 2 hexadecimal digits. That is their IPv6 global routing prefix. This is how the internet sees them. Now, here's what's amazing. What they have for a subnet ID, and this is not like, they got a big portion of IPv6. This is not big comparatively IPv6 address space, 340 undecillion addresses. They got a subnet ID of 32 bits. 32 bits, what is that for a subnet ID? 32 bits is their global routing prefix, but they have another 32 bits to create subnets. Look how many subnets they can create. 4.29 billion subnets. That's 4.29 billion. Remember, that's all the IPv4 addresses, right? That there are. Well, we reuse some, like the private IPv4 addresses. Okay, they have as many subnets as there are IPv4 public or IPv4 addresses. And by the way, each one of those subnets, 18 quintillion hosts per subnet. Okay. This is all about making it nice and easy to make your little subnets. All right, let's keep on going. If you got a /36, that would give you, okay, 16 plus 4 plus 4 plus 4. Let's stop right there. Okay, we got 28 bits for a subnet. How about here? 24 bits. How about here? 44 bits. Now, by the way, this is becoming more common, is for ISPs to start here. We'll see here in a moment. This is what they've been doing for a while. This is what Cabrillo has, right? Okay. I don't need that, actually. Move that and get the other one. Where's my terminal? Yeah. This is what Cabrillo has. /48. Let me actually, I can move that down a little bit here now. Okay. This is what Cabrillo has. We have a /. I'll get there. There you go. We have a /48. This is how the world sees us. Okay, 3 hextets, 48 bits. Okay, that gives us 16 bits for subnet ID. But what I was getting at is this. It's becoming more common to make, there's our /48. Did I get over too much? That's a /48, right? 65,536 subnets. /48. I want to make sure that's clear there. /48, right there. Okay, I think it was over one animation. Okay, 48 bits, 16 bits for subnet ID. There's my subnet. Okay, what I'm getting at is this. This is becoming increasingly more common. Let's give organizations /44s. We got the addresses. Why is that? Think of what that would do for Cabrillo. We could use this first hexadecimal number for different campuses. Okay? Yeah, we could give Aptos anything 0 through F here. We could give Watsonville campus. We used to have a Scotts Valley site many years ago. Okay, but we can have different sites. You know, maybe have another address for wireless. Okay, just different hextet start here, and then all the, anything starting with a, let's say anything starting with a C here, and all those subnets are here at the main campus. Let's say Watsonville, A for Aptos, maybe. All right. /48. So this is what Cabrillo has. Okay. /52 or /56. This is actually becoming common for households. Okay. Yes. Okay, I run IPv6 from home. I'll show you that address, if not today, definitely on Thursday. Okay. But a lot of internet service providers are giving /52s or /56 so you can subnet at home. Yeah, so you could have 256 subnets. Why would you want that? You might want one for your guest network, one for all your household appliances, one for business. Okay, what you do for work. Another one for what schools, why do you keep those separate? Well, definitely for work. I want to keep my stuff separate from, what I do for work, separate from what I do for my household appliances and that, but also just for organization, some other things. But, most people don't care yet. Okay. All right, the home of the future, /60, okay. All right, so let's take a look at where we're headed with addresses. Wow, look at all these addresses. First of all, let's talk about what's common in IPv4. IPv4, yes, we have unicast, we have multicast, and we have anycast. We also have one other in IPv4 that's a broadcast. I'm going to be spending some time on why we do not have broadcast in IPv6. We use multicast for everything. Okay, and I'm going to spend some time talking about that. Okay, now in IPv4, our unicast is really just a single unicast address. Yeah, we have some special unicast addresses. We even have what they call a link local, but it's really different. Okay, it's a PIPA address. We'll talk more about that a little later, but it's an address that, yeah. So, but anyway, but in IPv6, look, we have link local, loopback, unspecified, unique local, embedded. We're not going to worry about this. Okay, unique local, I'll talk about. Okay, you might get one on your computer. I'll show you. I get one at home. Or I get one on my computer, my Mac OS. Unspecified, it has a special meaning. You know, notice it, look, it's an all zeros address. That's kind of weird, isn't it? Okay. It just means, I'm not really giving you my address. This would be a source address. We'll talk about that a little bit. Loopback, yeah, we have that in IPv. We have that in IPv4. Okay. And we have kind of a global unicast, kind of a link local, but it's not used in IPv4. So we're going to talk on Thursday about this. We're going to have a separate lecture on this. Okay, I'll mention these here in a moment. Multicast, okay? Multicast is something we use in IPv4 as well. But we're going to see that we have these special multicast addresses. We actually have this solicited node. What in the world? Boy, that thing's ugly. Why did they have to make it so ugly? I don't know, but I'll talk about that. Okay, but that's good. That is something you will understand. You're going to understand multicast when we get out of here. Not today, though. By the way, so I mentioned I'm fortunate to be on a couple of podcasts, and on Friday, and they happen to be on both IPv6. I was a guest host, where the guest himself was this person here, Tom Coffeen. That was one. Russ White is the host of it. When he needs another guest host, he sometimes calls me. The other one was interesting, was a podcast being done out of Belgium, interviewing a lot of people involved in IPv6. And they asked me to be on from an educational perspective and somebody that's written on IPv6. And one of the things they asked me was, what are the things that students find most difficult about learning IPv6? Or what is some of the challenges? Okay, so yes, one of them I mentioned is getting over this fear of long addresses, or just the intimidation, whatever you want to call it, I don't know, but all of this. But I also mentioned how much easier it is to read once you get used to it. The other thing I mentioned several things, this thing here, solicited node multicast. Okay, it's like, oh, that's just, what in the world is that? And multicast and all that. Okay, but we'll get past that, and you'll see the big advantage of it. Okay. So first of all, here's the IPv6 address space. Okay, if we divided it into the first 3 bits, so basically we're dividing 340 undecillion addresses into 8 slices. Here's the global unicast slice. This is what we are using for routable addresses in the internet. We're not touching these right now. We don't need to. Now, we're going to talk about some of these other addresses in a moment. By the way, this is not to scale. Okay, we're taking a sliver out of the 3 zeros here for unspecified. Taking a sliver for multicast, link local, unique local. That's not to scale. Okay. But when I want you, and the global unicast, we're using such a tiny sliver of that right now. It's not because it's not being adopted. Yeah, we'll talk a little bit about that on Thursday. We're getting there, and we will get there, slow but sure. But the other thing is just there's the vast amount of IPv6 address space. Okay, so unicast address. Let's talk a little bit about the global unicast address. Okay, so the global unicast address is any address that really goes from with a 2 here in the first number or 3. okay, a 2 or a 3. And we'll see why in a moment, okay? It's actually because the first 3 bits start with 001. Okay, we'll see that. If not today, definitely on Thursday. But these are addresses that are globally routable. Okay, that's these addresses right here. See, global unicast begins with a 2. Globally routable. Okay, globally routable. The internet. Hey, we can get to these addresses. Okay. Now you're going to notice that in a lot, and I've already used this a lot already. 2001 DB8. These first 32 bits. There's an RC that says, let's use these for documentation. Okay, so when we write about IPv6 and you're doing examples, let's use this for documentation. Now, there's been a new RFC out on this, and they've extended that slightly. So for some labs as well. So I'll talk, I think it's, yeah, anyway, I'll mention that a little later. All right, these are the addresses we'll be referring to the most. Okay, but we can't ignore link local or multicast, by the way. Okay. Okay, so the global routing prefix. So how do we get that 2 or a 2 or a 3? The first 3 digits is 001. Okay, so let me kind of show that right here. Okay, remember if I have 0, and then this has 1 here, and this can be anything. This can be my first hexadecimal digit. Okay. Well, if it's 0010, that's going to be a 2. If it's 001, remember it has to start with 001. If the next number is a 1, then that's a 3. So that's why this first number is going to be hexadecimal 2 or hexadecimal 3. And if you remember when we went back, let me go back to my little pie here, pie in the sky, right there. That's the 001, the first 3 bits. Okay. So yeah, we talked about the subnet ID, the interface ID. We talked about that already. Global routing prefix, whatever. Your subnet ID is usually going to be your subnet ID. We'll talk more about this. We have 64 bits right here. This says, we need to have a 64-bit interface ID here. Subnet ID is going to be whatever this is, okay? It's going to be, typically from here to here, it's going to be whatever equals 64 bits, whatever we have left over. Okay, so if this is 48, we'll make this 16. If this is 32, we'll make this 32. Okay, but your global routing prefix plus your subnet ID will equal 64. Now, why 64-bit interface ID? We can talk about that on Thursday. How's everybody doing, by the way?
Fine.
Fine, good. Thank you, Roger. Pamela, good. Alex, good. Good to see everybody. Good. Lisa there, John, all the regulars. All right.
Well, if you're going to wake up this early, and so will I.
Okay. So, Roger,
Yes.
you're not going to like to hear this. I get up at about 4:45, 4:45 every morning. I think that's a little too early for most of us, though, right?
You sound like a baker.
Yeah, that's what I should do. Yeah. My brother told me I should get a paper route, but we don't do paper routes anymore. Him and I used to have a paper route when we were kids. Yeah. This is what happens when you get first of all, I do it. I'm more in person. When I had a dog that I used to take to the beach at 6 o'clock every morning. He's no longer, let me see, right back there, Luigi. So now I'm just used to getting up early. All right. So, let's take a look at some of this. This is just IP config on. So yeah, here, IP config on Windows. Okay. This is IF config on a Mac. You can see here prefix length 64. So this is actually, this is my home address. What, Rick? One? Okay, this is crazy, right? But it's good crazy. Look how many IPv6 addresses. This is my link local. We'll talk about that in a moment. Okay, I actually have 3 global unicast addresses. Now, something you're going to notice here. This one here says autoconf, secured autoconf temporary. Okay, so we'll talk. Oh man, I love this stuff because this you're going to see some cool stuff with IPv6. This is what we can't do in IPv4. Okay, let me just briefly explain this. Okay, this is an IPv6 address. So this is my network portion. This is at home. This is my network. Okay, this address here, temporary, is used anytime I initiate a connection. I go to Netflix, I go to Google, I go to Zoom, I go to Facebook, I go to LinkedIn, doesn't matter. Okay? This is the address me and whoever I initiated it with is going to use for me to communicate. Okay? This part will change periodically for privacy reasons. Okay, we'll talk more about that. Very cool. Very cool. This is an address I can use that's more permanent. Okay. This is an address that if somebody wanted to connect to me and I wanted to open that up on my router, my firewall, I can allow people or even me to connect to this device. Now, what about this one? Oh, it should be blue right there. This it got dynamically from a DHCP v4 server. Okay? Talk more about that a little later. By the way, here's my one lonely IPv4 address at home. Okay? But the beauty of IPv6 is it allows us to have multiple IP addresses, and we'll use them accordingly. We'll talk more about that a little later. This is, let's see, I need that. Okay. I'm showing you my school. Link local address. Let's talk a little bit about that because this is important. Okay. This is an address starting with FE80. Now it can start with FE80 to FEBF. It has to do with the first 10 bits. I'll talk about that in a moment. But you'll always see it as FE80, and you should always use FE80 if you statically configure it. Why would you statically configure a link local address? Rick, I don't even know what a link local address is. We can have a special one class on a lecture on link local. It's used especially with routers, but also with your computer. Oh, we'll see the beauty of this. In fact, we'll talk about it right now. A link local address is not routable off the link. It's only good between you and your router. Okay, that's nice. For an IPv6, I'm not sure why, but it's nice. An IPv6 device, if a device is IPv6 enabled, what it must have is a link local address. Doesn't have to have a global unicast address, but it means it has a link local address. Okay, so this is used by devices before it has a global unicast address. Okay, so before my device got this IPv6 global unicast address, it gave itself, yes, see this here, this is a link local address, FE80. It gave itself that address, okay, by itself. We'll talk more about that, okay? Now, the router is my, the default gateway is my router, and I'm going to use its link local address to send packets to. Because your default gateway, we'll talk more about this, but your default gateway has to be on your link. When we say link, we mean your network. Okay, your router has to be on the same network as you. So to guarantee that that default gateway is on your network, we'll use the router's link local address. We'll talk more about the advantages of all of this. Also, routers use it to exchange routing updates with each other using link local. Link local guarantees that, hey, you and I can talk directly. Okay. So we'll see that it's used, and I'll show some examples of this, even though for, we don't have to know routing yet. I'll show some examples of all this. But let me show you this. So a lot of times when you do IP config, you may not get an IP, you may not be running IPv6 on your network. But so you won't see an IPv6 address like it says here, but what you will see is a link local IPv6 address. Your device is already enabled for IPv6. Your operating systems are already enabled for IPv6. They will give themselves a link local address as soon as it boots up. So here's Cabrillo. This is actually, well, I can just show it to you right here. This is the link local address. Okay. All right, we'll talk about how it's used a little later. Yes, it is used. It's the one address my computer has when it boots up. And it can use this to get a global unicast address dynamically. Right? Here's my link local address at home, FE80, right there. Okay, loopback address, let's talk about that. Same functionality as IPv4 127.0.0.1. We typically, it's not routable. We usually use that to test the, internally test our we call our TCP IP protocol stack. We want to ping ourselves, things like that. We want to send packets to ourselves. Unspecified address is an all zeros address. It usually means, you don't need to know who I am. It's a source address. It's usually, I'm sending a packet because I need some information maybe from, we'll talk about this later. I'm sending something called a router solicitation message. I need a router advertisement message. And that's something you're not going to just send to me anyway. You're going to send to everybody. So you don't care who I am. We'll talk more about that. But if you don't need to know my IPv6 address, I can send it as a unspecified. The source IPv6 address, I can be kind of anonymous. Not that it matters, not really for privacy, just that you don't really care. Okay. All right, unique local address. Okay, this begins with FC or FD. This can be used similar to RFC 1918 addresses, those private IPv4 addresses, but we do not translate them to a global unicast address. So here at school, this is my private IPv4 address, right? And we know that's going to get translated to a public IPv4 address. Okay, what is my public IPv4 address? Rick is trying to speak slowly so he can show it to you. Here's my public IPv4 address, right? There's my public IPv4 address. So this is getting translated to this as the source IP address going out and coming in as this destination IP address getting translated by the router using network address translated to this. Okay. That is not what this is used for. Matter of fact, you will see okay, not doing it here. Interesting. Must be just, okay. I'll show you tell my home address. I get a unique local address. Okay. But it's not routable. Now, why would we want to use this? If you want to have, you can route it locally, but it's not internet routable. You can, if you want to have addresses, you want to have some addresses. Now, again, your computer can have both. okay, can have this unique local and it can have a global unicast address. But maybe you have devices that you only want accessible from the inside. Now, firewalls, your router, access control list, you can control that. But you can use a unique local address to say these are devices I want to make sure are only accessible from the outside. I'm sorry, only accessible from the inside and never from the outside. Okay. Again, knobs. You don't have to use all the knobs, right? I, you know, used to have stereos with all these equalizers and stuff like that, and keep everything in the center as a default. Fine. If you know what if you have a special reason to turn knobs for more whatever to equalize things, bass, treble, and all that. I don't know any of that stuff. Okay. Yeah, use the knobs. Okay? But if you don't need to, don't touch the knobs. Okay. You don't need to use it if you don't need to, but it's there if you need it. Okay. Let's see. This is my. Let's see. That's school. Here's my home. Oh, I had a right there. See this address here? That's a unique local address. Yeah. Do I use it? No. Okay. The addresses that are used are really primarily these three. We'll talk about it. My link local address, we'll talk more about that. And we'll talk about these two global unicast addresses auto-configured. All right, how are we doing? Tell you what we're going to do on Thursday, bright and early. Okay. We are going to talk about the global unicast address specifically. Okay. So we're going to talk about, subnetting. We'll talk about how you get a global unicast address, statically and dynamically. Okay. We will see that in the world of IPv4, for example, in the world of IPv4, okay, when we choose for IPv4 here, let's see if I can. Okay, here's my IP. In IPv4, I have the choices DHCP or really manual, or I can using DHCP with a manual address. That's something, but it's DHCP or manual. Notice with IPv6, all it says here doesn't say DHCP. It says automatically. All right, okay, don't worry about this link local. I can do manually or automatically. Automatically means, hey, there's probably more than just one option. We'll talk about that. The answer is yes, that's true. We'll talk even more about that later. DHCP is just one of the options in IPv6. Okay, so at home, so we'll get there later. But yes, you can use both DHCP or something called stateless address auto configuration. This is one of the big benefits of IPv6. You don't need a DHCP server assigning you from a pool of available IP addresses your unique address. You can create it yourself.
I have a question about that panel.
About which panel?
The one configure IPv4. So I was playing around with my computer and I turned it off, or maybe I did manually. I don't know what I did. And my internet just stopped working. So I thought maybe I had a virus or something. So I looked at this. Oh, it's using DHCP. It's not set. So let me reset it. And then it worked. So say hypothetically, I did not want to use using DHCP, and I picked another option to say the second one.
Okay, manually. Yeah, you have to make sure your manual address, okay, you have to make sure that when you do your manual address, you need to make sure that you have the right subnet mask and right default gateway that is remember your router has a default gateway address. You need to make sure that you have a IP address and subnet mask that's on the same network as your router, or you won't be able to get out.
So if I use the second option, can I actually set
You can
it?
create your own. You can create your own, but you need to make sure that you give yourself an IP address and a subnet mask that's on the same network as your router, and also make sure you put a DNS server address.
So what IP address would I use then? The same one?
You have to. What's your router's IP address?
I don't. I mean, I'd have to check what it is, but
You have
what?
to check what your router is. So your router is going to have an IPv4 address and a subnet mask.
Okay.
It says, this is the network I'm on. You need to make sure you're on the same network as your router.
So I just pick 172.30.1.
Well, don't, this is mine. This is the network I'm on.
Yeah, but I'm using yours. I would just, instead of using .10, I can figure it .5, and that would work.
You can use anything from, well, .1 is being used, so you can use, assuming there's nothing else that's going to conflict with it, .2 to .254.
Okay, thank you.
Okay?
Okay.
Yeah. And good question. Yeah, this is why, and that's a great question, Roger. This is why we use DHCP, because it's not just this, it's also, by the way, DNS. Okay, we want to make sure we have the right DNS server address. If we don't have the address of a DNS server, it's going to look like you don't have a internet connection. You do, but you can't do anything because you don't have a server that will translate this to an IP address, wherever you go, Google or whatever, it doesn't translate it to an IP address. If I go to, I don't know, but make sure it goes something like here, okay? This is the DNS server is giving me, my computer, the IP address to connect to www.netacad.com. If you don't have the DNS server, the right address here, or missing it, you're not going to be able to do anything on most things like the World Wide Web.
So it's always better to have the computer figure it out, because say I go to a coffee shop or
I'm
something,
glad you brought this up.
automatically. Okay.
Yeah, because in the old days that wasn't the case before DHCP. So you want to make sure that you have the DNS server. You also want to make sure that you have. This is why we don't want to do this kind of stuff manually, okay? Because if I start configuring this stuff manually, okay, I'm going to cancel this, okay? If I configure this stuff manually and I'm wrong, I'm going to have problems.
So
So you want, and just to kind of bring this home a little bit.
So it's funny what happened. First, I could not go to a couple of sites, and then on other sites, CSS will not download. Then all my websites look funny. And finally,
You've
nothing
lost
worked.
all connection. Yeah.
Okay.
Because this is your router. This is your way out. Okay. You have to have an IP address that can communicate with this device. So let's say, so I'm going to leave the recording going. If people need to go, I understand, but I want to talk about this a little bit. So if this is your address, okay, what happens is this. If your computer has a packet to send to, let's just say the IP address 7777, say that's Amazon or something. Okay, this is the destination IP address we need to send the packet. Your computer goes, I'm on this network. Okay, that's my address. This is the destination address. You are not on my network. Okay, so first thing is, what's my router, my default gateway? Okay, first of all, it has to recognize that you're on a different network. Then it says, I know my router's 172.30.1.1. So I'm going to send this packet to the router. So I'm gonna send out an ARP request. Hey, 172.30.1.1, what's your MAC address? It says my MAC address is AAA. Okay, so it says, great, I've got that. I can now encapsulate this in an Ethernet frame with AAA and send the packet to the MAC address of the router. Now, that's how things are supposed to work, okay? If you don't have this right address or this is wrong, you're gonna have problems, okay? If you put yourself on a different network than the router, let's say we put ourselves on, now we're on a different network. This is the network of the router, 172.30.1.0. We're on 172.34.0. Your PC can now no longer, it thinks I can't reach, even if I knew the router's IP address. I don't know how to get there because you're on a different network than me. So we have to make sure we're on the same network with an IP address on the same network as our router. Okay, it's like having a letter you got to take to the post office. Okay, the only way you can communicate with anybody outside your neighborhood is with your local post office. If you don't have a local post office, or if you think it's in another city, you're not going to be able to send letters anywhere else. So it's critical that this is on the same network as this, and you have things like a DNS server address and things like that. This is why we want to use DHCP. We want the router who's acting as DHCP server to allocate this information to us. Okay, it's giving me an IP address, subnet mask, self as the default gateway, and the DNS server address, okay? It's gonna make sure it's doing things correctly. Less chance for me to mess it up. Does that make sense?
Yes, it does.
Yeah, good question. All right, I'll let everybody go. Good stuff, good questions. I always like stuff like that because it helps us understand, it's no different in the world of IPv6, by the way. Same idea, just different addressing. All right, I'll see, hopefully, some of you, most of you, all of you, I don't know, none of you, I don't know, on Thursday morning at 8 o'clock. All right, have a great day, everybody.
Hey, Rick.
You too.
Thanks.
Hey, Rick. I had a question regarding the participation
Recording